Points of inflection. On this curve, the gradient at this point is about 11. Around here the gradient's about 10, 8, 5, 2, 1, and then the stationary point where the gradient is 0 and the gradient becomes negative. And then around here the gradient then starts to increase. What you'll see from the numbers is the gradient is always decreasing. It continues to decrease until we get to a certain point, and then the gradient starts to increase again, and so on. So what we have is a decreasing gradient along here. It's still decreasing, the gradient is still decreasing until you get to a certain point, and that's your point of inflection, and then the gradient starts to increase from there onwards, and on this curve it continues to increase. So there's something special about this point here. It's called a point of inflection. It's where the curvature of the curve changes. It's a point where the second derivative is equal to 0. Now sometimes points of inflection are also stationary points, but that wasn't the case in this example. On this curve, let's say the gradient here is 8. The gradient here is 7, 4, 2, 1, and then we've hit a stationary point where the gradient is 0, and then the gradient is increasing 1, 2, 4, 8. So what we see is a gradient that's decreasing. The numbers for the gradient are getting smaller. They're getting smaller, they're continuing to get smaller until we hit a particular point, after which the gradient starts to increase. Okay, so the gradient is still increasing here. So again, this point here, other than it being a stationary point because the gradient is 0, it's a point of inflection. At this point, d2y by dx squared is equal to 0, and the gradient on either side has the same sign: positive gradient, positive gradient. Same with this example. With this point of inflection, right at that point, the second derivative d2y by dx squared is equal to 0, and the gradient, so not d2y by dx squared but dy by dx, the actual gradient, has the same sign on either side of the inflection point. So the gradient on this side is negative, on this side it's also negative. In this example, let's say the gradient here, it's negative, let's say it's minus 8, minus 6 here, minus 2, minus 1, then a stationary point, it's 0, and then just by symmetry that's 1, that's 2, that's 6, and that's 8. And what we see is minus 8 to minus 6, the gradient is increasing. So on a number line, if you go from minus 8 to minus 6, your values are increasing, and then increasing again to minus 2, and still increasing, and still increasing, and the gradient continues to increase. So what we don't see is what we've seen here, where the gradient was decreasing, and then it stops decreasing, and then it starts to increase again. Point of inflection. Or in this graph, where the gradient is decreasing, it continues to decrease, and then it stops decreasing, and now it starts to increase. So we're not seeing this behavior on this curve. So in this region there is no point of inflection. we just have one stationary point, but that's not a point of inflection. So a point of inflection is a point on a function, on a curve, where the curvature changes. More of curvature in the next video. And where d2y by dx squared, the second derivative, is equal to 0, and where the gradient before and after the point of inflection has the same sign, so negative here, or in this case positive here, positive here.